Hello Connections, I'm Mallikarjun. So as a part of the Spark Foundation internship program, this is the task wherein I need to predict the stock market using numerical and textual data. Uh, so initially I imported libraries, that is basic libraries, Math, Pandas, and NumPy. Then for visualization, Matplotlib and Seaborn, Keras for building my artificial neural network, and LSTM for which is a long short-term memory. That is a special type of RNN. I've also imported NLTK, which is a natural language toolkit. Then sklearn metrics pre-processing also, which helps in my post-processing metrics, which helps in the performance and also pre-processing. Then I have imported Y Finance, which is nothing but Yahoo Finance, wherein I'll be importing data, stock price data. And for my stock news headlines, that is textual data, I've imported data from here, Times of India news headlines. Then this data I've downloaded into my drive and linked here. So stock price, I've taken off BSCSN. Then its starting date is from 2015, January 1 till 2020, December 31st. And this is stock price data. This is stock headlines data. Next is feature engineering. Initially, I've checked the records of stock price and stock headlines. Then I've checked whether there are any null values in the data, which is false and everything. Then I've checked in stock price data whether there are any duplicates. If so, then drop it. Then later in the stock news data, I've if you can see like the index is here date, but for headlines the index is just a normal natural like 0 to n numbers. So I need this publish date into somewhat in this form. So this code does it. Here it is. Then later I've combined the stock data and the headlines data into just one single data. And also if you check here, it's from 2001. The textual data is from 2001 till 2020, but I need only from 2015 till 2020 because numerical data is only what I have is of 5 years. So you can see here 2020, 12, 30 numerical reading of something. The headline is something new, that is numerical readings. You can see here it has taken, it has combined. Later, I've like put the columns of sentiment scores, that is compound, negative, neutral, and positive. And also I've calculated it using a sentiment intensity analyzer, that which is a part of NLTK. Then I've calculated it here. Next is finalizing stock and writing to my desk. So here I've finalized the data. So you can see I don't have headline text. Here you can see like I've calculated its negative, neutral, positivity from my sentiment intensity analyzer. That is like how much negative, neutral, positive this particular headline is. So I no more need this. I need to get rid of this column. That's what I've done here. Later, I've written it to my disk, and then because I can use it later to my whenever I need it. Then I've imported the same stock data. Then feature engineering of stock data. I found out the shape. Then I found out if there are any null values. Again, it's false. Then later I found out the statistics of it. That is uh, the count, mean, standard deviation. Then later I found out the information, found out whether there are any null values, there are or non-null values. Then found out the data type, which is float 64. Next, I've done exploratory data analysis. I plotted the close price with respect to date. Here it is. Then rolling mean. I found out the rolling mean for 7 days. That's why the first 7 days remains null. Then later from here it goes on calculating the mean for every 7 days. Then here you can see I've plotted it. Also you can see here for first few days it won't get plotted because yeah because first 7 days it remains null. Next is data modeling, data preparation for modeling. I've used I've used 80% of this data as training data and just for test. Later, I've shifted the data to create timestamp. That is to calculate close price shifted and compound price shifted. Uh, that is for timestamp -1. So you can see here I have close price shifted, compound price shifted, volume, open price, high, low. Later, I've set target variable, that is close price shifted. Then features, that is close price, compound shifted, volume, open price, high, low. Later, I've scaled the data. But the scaling here means since we are using LSTM to predict stock price, which is time series data, it is important to understand that LSTM can be very sensitive to the scale of the data. So right now, if the data is observed, it is present in the scale in different scales. So therefore, it is important to rescale the data so that the range of the data is seen. So for almost all records, here are the range we used is -1 to 1. Next is dividing the data set into training and test. Because normally for any other data set, train test split from escape package is used. But for time series data like stock price, which is dependent on date, the data set is divided into train and test data uh, in a different way as like shown here. In time series data, an observation for a particular date is always dependent on the previous date records. Next, I've reshaped the feature data. Later, uh, I've modeled the data. So I've used LSTM and activation TANH because TANH is what used in LSTM. Later, you can see here the summary. Then I've fit the data. You can see for like I've run it for 10 epochs. Then the loss I got is 0.017, which is 0017, which is quite less, and we are good to go. Then I've saved the model to my disk, so into a JSON format and H5 format. So the JSON format I can use it to build any website and do many other things also using H5. Next is predictions. This is the predictions of the validation data. Next, I've evaluated the model, found out the train loss and test loss. then root mean square, using scalar metrics and the normal way. Then I've plotted the predictions against unseen data, which is the 20% of the original data. So we can see here the blue line is the predicted one, and the other line is the original data. So we can see it has plotted very well. It has fitted very well. The model is fitted very well. And below is the references. So that's the end of the project. I thank the Spark Foundation for giving this unique project. And also, I'm open for the discussions. Thank you.